I'm Jenny Smith with Missouri State Highway Patrol Crime Lab, and I will be introducing our distinguished members of the panel for this panel entitled Things That Go Boom. Obviously, the Symposium Steering Committee struggled with a name for this diverse collection of talks that we have for you this morning. So I would ask that you write down your questions as we go and save them for the end after the last speaker has given their talk, and we'll have about a 10-minute question and answer period at that time. We will start this session with a talk by David Flohr from the U.S. Army Crime Lab in Forest Park, Georgia. His talk is on the pyrotechnic reaction products of a different kind. I believe this is dealing with some hand grenade residues.
Thank you for attending this session. I'd like to thank the FBI and the NIJ for sponsoring this and inviting me to speak. This work is a collaborative effort between Lee Fadness, James Garcia, two analysts at our laboratory, and myself. There's our general disclaimer: whatever I say, the Army, they disavow any knowledge of me. Okay. Normally when we think of pyrotechnic reaction residues, we think of fireworks and gunshot residue, and the collection of those by SEM adhesive stubs and the analysis of those in the SEM. And there's the adhesive stubs. We think of round particles such as the ones with the water around the dog, because it's a natural, because of surface tension, things that coalesce from a heated environment make round particles, such as these in gunshot residue. And in our laboratory, we've done a lot of work. We first started doing SEM EDS for gunshot residue with an XL30 variable pressure microscope, 4-stub holder, and we use a Plano standard. The first situation I want to talk about occurred in Kuwait before we went into Iraq. The individual in question ran down this line of tents throwing grenades inside, and the first tent he threw a thermite grenade in. He fled the scene and was apprehended in a remote area. The GSR stub, which was taken of his hand because he shot individuals as they exited the tent, so they wanted a traditional GSR exam, was negative for GSR. But those same stubs held particles which were barium and chromium rich, and they were in the unclassified particle list. So the question was, what were those particles, and could they be used to link the subject to that actual area? Well, to know something about the particles, you have to know something about the M67 grenade. Obviously, it's an anti-personnel grenade. It's used for offensive work in the U.S. military to kill or incapacitate the enemy. It's made of two essential external components: the M213 fuse, which is a cast zinc body. That'll become important later. And a low-carbon steel actual body itself, which produced fragments. It has a couple of unique components that if you think grenades were thrown, you should find these on the ground in the local area. They would be this jungle clip, which is only used on the M213 fuse, the ring and pin combination, and mainly it's not the ring, but it's the pin and the crimp on the pin. And then there's the lever. The lever is obviously marked M213. It's the only thing the M213 fuse is used in is the M67 grenade. And it has a lot number which can be used to track that grenade. Here's an example of a soldier throwing it. You can see the lever coming off. Just for information purposes, the kill radius is about 15 feet. The casualty radius is within 50 feet, but fragmentation can go up to 750 feet. The internal components consist of a spring-actuated firing pin, which slams over on the top of a primer, M42 shotgun primer, which produces traditional GSR. A gasless delay mixture, which the primer initiates, which then initiates the detonation of the blasting cap, which then the det wave from the blasting cap and the comp B on the inside produce fragments from the encoined surface. The surface is as patterned to make small particles for fragmentation, which are typical like these. There's a 1 millimeter scale in the field of view. So these fly out in every direction to kill or incapacitate the person that's trying to be attacked. So this is an engineering diagram of that M213 fuse from the side. You can see the firing pin underneath the lever, which flies over, would hit the primer. And what I'm going to deal with is that delay column, which is in the middle. It's about 20 millimeters high, 0.8 inches, and 5 millimeters in diameter. Contains about 1.29 grams of material. That material is barium chromate, which would be that barium and chromium-rich material that was found on those GSR stubs. Nickel zirconium alloy, which is the fuel, and potassium perchlorate. So we have two oxidizers and a metal fuel. That's a picture on the stereoscope of that delay mixture I got from the manufacturer. And this is it in transmitted light. And the picture I like the most is this one, which is cross polars, first order red plate, and top lighting. So you can see the barium chromates in the yellow, the black particles are the nickel zirconium alloy, and the potassium perchlorate has the yellow and blue interference colors. You would rarely ever find that unless somebody was actually digging it out of the M213 fuse, but I thought that you might want to see that because I think it's pretty. Well, we had this case, we had to actually make the residue. We never had this, so we had to take some, build a box to contain the grenade, and it was made out of a 3/4 inch plywood exterior, a 1/4 inch medium density fiberboard, and then we lined it with cloth because the residues were not taken only off his hand stubs, but also off of his uniform. So we had the same kind of cloth in the interior of the box. And we sealed it all together with 4x4 posts, lag screwed it together. We put a hole in the top. We were thinking EOD was going to drop the grenade in, but they didn't want to do that. They decided that they wanted to blow the grenade spoon off with det cord, which added a little bit of excitement to the whole test. There's our box, and I don't know if I have time to show this because it's kind of long, but here's the results of the detonation. Actually, the box was fairly well blown apart by the det cord. In the corner, the grenade apparently wound up in that corner, and that's where it did a lot of damage. So we took the cloth off the inside of the box, folded it in on itself, went back to the lab and stubbed it for residue. Again, I used our microscope. We analyzed all our GSR and variable pressure uncoated samples, and but we changed the element categories that are used in a traditional GSR routine. And I faced this in court. They asked me if I was using an untried method. I said, no, it's particle analysis, automated SEM EDS, analogous to GSR. The only thing we did was change the element suite that we used. And these were the categories: the barium, chromium, nickel, zirconium, potassium, and chlorine, and you can read the rest. We didn't know what we'd find. Well, here's some of the typical particles we found. Those are the fairly larger ones. They get nodule like that, and there is the elemental composition. One thing we did find was the potassium chlorine kind of would come and go. It was the one thing that would come and go, but you get the addition of the zinc from the zinc fuse body, and also was a healthy concentration of aluminum, I think because of the shield of the blasting cap, the reservoir that the blasting cap material is in the interior of the grenade. Situation number 2. The suspect had intimated he wanted to do something to his commanding officer, obtained a claymore mine, and put it in the windowsill and detonated it to kill his commanding officer, and there happened to be another officer in the room. He then threw from a position 3 M67 grenades to make it look like it was actual mortar attack, because when they lob mortars at us over in Afghanistan or Iraq, there'd be several mortars come in and everybody hunkers down, and then when you don't hear any more noise and people pop their head up like gophers, and is it clear? And then they go on their merry way. So he thought, boom, 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 everybody will stay hidden while I make off and get out of the way. He was arrested 7 days after the incident based on other things, the things that he had said which intimated he might have something to do with this crime. There's the actual, was one of Saddam's palaces, and on the roadway, actually after everything happened and people popped their head up, our subject was actually standing on the roadway. He took the claymore mine wire and the clacker and threw them in that lake, and then from a position down beside, let me go a little closer, there's the window where the claymore was set, and they tell me this laser pointer doesn't work real well, but it's a left-hand window on the windowsill, and then I want to show that. See the vegetation coming away from the building? We think he stood beside the wall, down near the water, detonated the claymore, and then threw 2 grenades, and then ultimately, here's a picture of where he could have stood down there on that sandbank. It wasn't sand, it was actually like mortar mix that they coated the side of the wall so it wouldn't erode. And then he threw 2 grenades and then came up on the road and threw a 3rd grenade. Well, they wanted to know, were there 3 grenades thrown? Well, we had the clips, we had the rings, and we had the levers. We wanted to know where they landed. And we also wanted to know if there were particles of the fragmentation in that area, were there explosive residues in that area. Then I thought, if we don't have frag, and if we don't have explosive residues, because 2 of the samples, actually all 3 of the samples didn't have TNT nor RDX in those soil samples, or in this sample was actually on the roadway. So there was no explosive residue. I know we could look for the delay composition because it's everywhere. So we collected, analyzed the 2 soil samples and the debris from the roadway and found this delay element at each point. They had collected his carrying bag thinking that he had come to the crime scene maybe using this bag because he carried it all the time with the Claymore mine inside and the M67 grenades secreted inside. Everybody used to see him with it, and even if it was kind of heavy, nobody would kind of think it was out of place. So they collected that, and they also collected his gloves. I stubbed the bag and I was thinking the underside of the bag, the underside of the flap, because you'd have to have it open to get material out of it. And then his gloves. Now the gloves, if you've ever been in Iraq, which hopefully a lot of us in this room haven't, but if you see our soldiers coming back, they're coated with dust. I mean, it's everywhere. You see the sandstorms. Well, these gloves were just coated with filth. Actually asked for his uniform, received his uniform, and his uniform was pristine clean. Delay element particles were found in that bag and were found on the gloves. And so now we have positive residue on our subject's bag and gloves, which could have been used during the crime, or could have been worn during the crime and carried at the crime, and, but nothing on his uniform. Well, the lawyers had another question. Well, can we tell anything about the dispersion of the particles? Where does this stuff go after the grenade goes off? My first inclination was, because the fragmentation goes 360, that the delay element mixture, which is right there in the core, would go 360 degrees out and could be deposited on any surface nearby, including anyone standing in that area. Well, they wanted to test that to see if they could put him in a particular location being doused with this material, more so than in another location. To do that work, I came up with the idea of using, like they do for gunshot residue, witness panels on a range. A metal fence stake was put in the ground with a 2x2 plywood covered cloth panel, and then centered about 4 feet above the ground, so it'd be center mass for a person. And there's an example of what was on the range. My staple job on the cloth wasn't so hot, was it? I should have had it flopped over. We did these at 3 different radiuses from a grenade going off to see how far would the residue go. In essence, we could have done one test, but because our range wasn't flat, we were bounded by hills on either side, which our limiting radius could be 90 feet. So then we said, well, let's go half of that's 45, and let's go in the middle of that at 67 and a half. And because of maybe inclement weather coming in, we thought, well, we'll at least do one and see if we can do all 3. And then we'll take our data and see where it goes. So here's our first set of 12 panels, 30 degrees apart, with the top one at due north. The next one is 16 witness panels. Tried to keep about the same degree reading between panels, separation between panels. And then the last one was at 20 witness panels, about 18 degrees apart. And so then we had actually 3 concentric rings. Now, these weren't done all at the same time. The first one was done, then the panels were taken down. Then the second set were set up, then they were, because I didn't want one panel blocking another. And that day, I noticed that as we detonated grenades and we went down to the range to make collections, we had a preferential wind direction, thank goodness. Well, it was that good, bad, or indifferent. It was what it was, from the southwest to the northeast, all day long. There's the range with me standing in the middle with the first set of panels at the 45-degree radius. And you'll notice a pile of sand in the middle. I put 3 bags of play sand in the middle to try to hopefully keep any residue from, this is an actual range at the military base at Fort Bragg. And if there's anything resident in that soil, I didn't want that getting in my debris. Well, what else could I do besides put a steel plate down? And that would have been a good idea. The EOD tied the grenade to the stake. They decrimped the pin a little bit, tied a string to it, a 550 cord, and went off over a berm, and they would literally just pull it. The smoke coming up and then dispersing. And that's the site of the detonation in the middle. So there's the collection, 15 sticks, half-inch stubs, and 5 to the left, 5 to the center, and 5 to the right. Now, I know half-inch stubs. It's a 2x2 foot panel. It's only about 5%, not even 5, it's a 0.5% of the total surface area. But what are you going to do? You got to do something. So I took them back and ran every single one of them. You got to look at all the stubs, exhaustive 100% analysis on that with that same elemental suite, and came up with particles, looking for particles pretty much of that composition which we'd seen before. There was one at the north, 25, you can see the numbers. Basically, the particles wind up in the northeast quadrant where all the smoke goes. and isn't smoke mainly composed of particles? Okay, is that any great shakes? But the interesting thing I found is on the second one, they're still in the northeast, but there's nothing in any other, you would think probability that if it went 360, you'd find particles somewhere on some panel for the number of panels, but they aren't. They're not there. And then the last ring, there were 11 and 6. So what do these things look like? Well, as traditional GSR, if they're very large, well, these are maybe 5 micron. They get nodular. And then you'll have what I call massive irregulars. These are really big, 5 microns and up to, say, 15 microns across, which have that same composition. And you also get, which actually were on the gloves and on the bag, were more of these kind of particles, which were really small, 1, 3, 1.5 micron sized particles, which still had that composition. Other indicative particles we found, which we actually initially ignored, but in going back and having made up the PowerPoint for this, I wanted to relook at our range study particles. You would find, obviously, from the steel body particles of iron, which would have a healthy zinc composition as a result of that cast zinc from that fuse. You'd find particles of aluminum where that aluminum shield for the blasting cap might itself just vaporize, make aluminum spherical particles, and just deposit on a nearby surface. The one I found most interesting, though, well, there's another one. In some of the particles, you'll get missing elements. Nickel zirconium alloy is pretty high, but why is the nickel so low? Zircon's okay, but nickel's kind of really low there. But that's what you find, as in traditional GSR, elements are coming and going. We relied on the full elemental composition to call a particle. But then you could have indicative particles, such as this one. Even though nickel's present, I would call that nickel being present. There would be times when it would be totally absent. There were certainly times when potassium and chlorine were totally absent. But they were indicative particles. They had the morphology and the general 3/4 of the elemental suite. These are the ones I found which were most interesting, in that if someone were to detonate one of these and they're in the area, you might actually find quartz particles that are splattered with zinc. So that one on the right is about 30 microns across, maybe 40, and a nice splatter of zinc on the surface. Initially ignored that one, but there it is. If I found that on your clothes, but I didn't find the ley element particles, how would splattered zinc get on your clothing? I mean, how would that? It would have to be some high heat event, which could be from a high order detonation. If you're questioning the forensic utility of this, we've used this in these 2 cases. I've used it in another case where an individual was suspected to have had somebody roll a grenade on him so that he could actually obtain a Purple Heart with one superficial wound, most of them being protected, part of them not being protected. Then I'd ask you to consider, on June 24th, while I was making up this presentation, in the news, Seattle terrorism plot was foiled, and there were 2 men who were arrested by the federal agents. They planned to attack a military processing office in Seattle with guns and grenades. So now take that incident. What if that had gone down and the subjects could flee the area? Then could you, as an analyst, do a traditional gunshot residue analysis with this elemental suite and look for these particles? Because if they're in that atmosphere of that smoke, like they would be in a gunshot residue realm, you could find these and therefore put them in that location. In our first instance, the individual who had run down the line of tents, there was no reason for him to be in that area. He didn't have to cross that area to go to the latrine or the PX commissary on that military base in Kuwait. That was an officer's area. Now, granted, everybody that was in that area had those particles, but he was found a good distance away, hiding, because it was suspected to be a mortar attack, and he was hiding, and these particles were found on him. The particles helped put him in the area of that dust, that delay element. It's also very important to know that day which way was the wind blowing in Kuwait, because could the particles be carried to where he was hiding, and he be in that environment and have them on him in that environment. So though it's a different kind of particle, I look at it as gunshot residue on steroids. Might not be something that you would see every day, but if this presentation has spurred you on to change elemental suites in order to use your automated gunshot residue program to find other debris, then so be it. If it's enlightened you as far as what we have, and if you have a grenade case, you can call us and we'll help you figure it out. There's a ton of physical evidence from the grenades themselves, obviously the ring, the pin, the spoon, which would tell you what happened. But what about the subject who's not at the scene? This residue is easy to find, easy to collect, easy to find, and very characteristic. And with that, I'd like to thank you for your attention.